Hello everybody, this is Miss Pi. I am doing the review video like I promised I would. Hopefully it'll upload onto the YouTube fairly quickly. Just a couple of caveats before we get started. I'm going to go through this as fast as I possibly can because there is around 50 questions, and if I go into huge detail on each one, it's going to take a long time. So a couple things I've done is any type of graphing, I've already done it and I posted a picture and then I'll just talk about it. If you guys need help remembering how to perform certain operations on the calculators, I will help you during the review in class the day of the test. Like I think we have an hour and a half to review before you guys take the test. So we'll do that then. All right, so let's go ahead and get started. The first problem is you have two different functions and you want to find the domain of the composite of f of g of x. Okay, and so what I did is I graphed f of x and I've graphed g of x. And then there's two different ways you can graph the composite. The one way that I like, I kind of cheat, I guess. I don't know, not really cheat, but I'm kind of lazy. Because I did f of x here, I tell the calculator to make a composite of f1 of f2 of x, which is the same thing as f of g of x. Okay, and then that's the green line back here. The other way you could graph it is because g of x is inside f of x, then you just replace the x here with the equation of g of x. Okay, so you can see that both of them will give you the exact same graph. All right, so the reason why I graph this is because we're looking for the domain. And yes, there's lots of rules that you can memorize to remember how to figure out the domain of a composite, and it's related to like the domain of one formula will kind of supersede the domain of the other formula. Anyway, I don't worry about the rules. I just graph it and I look at it. And as you can see here, it looks like you have an asymptote at x equals, let's see, 1, 2, 3, 4, x equals 4. And so your domain would be from 4, and notice I use parentheses and not a bracket because if we have an asymptote there, then we cannot actually land on 4. And then it goes all the way to infinity. And I know I said I wasn't going to graph this, but I just want to make sure that I'm doing this right. So I'm going to go ahead and graph it super fast, and I'm going to graph this one here. So just 1 and square root of x minus 4. Is it squared or anything? Yep, it is squared. So let me square it. Oh, my denominator squared. There we go. All right, so let's graph it. So here's my graph, and honestly, I already know what the graph looks like because I pulled it up. I already had it up there, but I want to look at the table. And I said when x was 4, we would have an asymptote there. And because it says undefined here, that tells me, that just confirms that yes, we do have an asymptote. The reason why I say that is because for g of x here, you can actually land on 4. So you can't just say, oh, it's going to be the exact same domain as g of x. And it's definitely not anywhere close to the domain of f of x. So easiest thing to do when you're figuring out the domain of a composite is graph the two functions or just graph the composite, okay? And that will help you figure out the domain. All right, problem number 2, find the remainder when this long polynomial is divided by x plus 2 and by x minus 4. So what I've done is we have two different binomials that we're dividing this polynomial by. And so the first time I did synthetic division, and the second time I did long division. You can use either method, it doesn't matter. With synthetic division, all you're going to do is write the coefficients, and these numbers up here where I got all the coefficients. And then notice with x plus 2, I switch this sign, so my term in my little corner box is -2. The first thing I'm going to do with the 3, excuse me, is I'm just going to drop the 3 down. Okay, and then I'm going to do -2 times 3, which gives me -6. And then 29 minus 6 gives me 33. I do -2 times 33, and I get -66. And 99 minus 66 gives me 33, which again gives me -66. Feel like a broken record almost. And then -453 minus 66 gives me -519, times -2 gives me a positive number of 1038. I combine those, I get -1314, and that is also multiplied by -2, and I get positive 2,628. I do the math, and I get a -108. Okay, next method that you can do is long division. I did long division with the x minus 4, and with that, you have to ask yourself, what do you need to multiply x by to get 3x to the 5th power, and you have to multiply it by 3x to the 4th power. Okay, 3x to the 4th power times x gives you positive 3x to the 5th power, and then times 3x to the 4th times -4 gives you -12x to the 4th power. But remember, with long division you subtract, so this positive becomes a negative and this negative becomes a positive. This becomes 0. Add those two together, you get 51x to the 4th. And what do you need to multiply x by to get 51x to the 4th? Well, you have to multiply by that, and you get positive 51x to the 4th. But then you also have to multiply -4 by that, and you get that. We get a -204, excuse me. Also notice that we drop down the 99x cubed. Okay, so remember again, with long division, you're subtracting, and you get this. And so we're going to multiply by 303x squared. And I can probably drop this down a little bit, make it a little bit smaller. Notice we're dropping down the 453x squared. We multiply this by -4 to get negative this, but then you change the signs, you get positive. Do the math. Sorry, I know I'm going through this pretty fast. You can totally put this all in the calculator to verify my answers. And we're just going to keep repeating this process. I'm going to go ahead and just uncover everything. So we're repeating the whole process of matching what we have here, multiplying this by both of these terms to get this, do all the math. And this one, our remainder is 0. And I didn't talk about the remainder of the last one. This time our remainder is 108. Okay, so the first thing you had to do for problem number 2 is to find the remainder. So for here I got a -108. Here my remainder was 0. And then it says which binomial is a factor of the polynomial. So anytime you get a remainder that is not 0, that tells you that that factor is not that number is not a factor of the polynomial. So this x plus 2 is not a factor, but the x minus 1 is a factor because we got a 0 there. All right, moving on to number 3, sketch the graph of this. And let's pretend for a little bit that you're not going to use your calculator to do all that, and you're going to actually factor everything like I'm sure you guys are all going to not do, but I'll show you really quickly. You can factor those. Just remember that the denominator tells you where your vertical asymptotes are, your numerator tells you where your x-intercepts are, and then because my degree for the numerator is equal to the degree of the denominator, my horizontal asymptote is going to be at y equals 4, And then to find my y-intercept, I plug in zeros for all my x's, and I'm left with -9/4. So my y-intercept will be at 9/4, which I think is like 2.25, I think. Okay, and then with all that information, you can graph the function by hand, but we all know that not a single one of you are going to graph it by hand. You're all going to plug it into the calculator because for the final, you have 50 questions and it's going to take a long time, so we're going to save time. So here's our intercepts that we got from our numerator. Here's our vertical asymptotes from our denominator. Here's our horizontal asymptote from the leading coefficients. And let me see. Oh, and the y-intercept. And then notice here that my graph in the middle does cross the horizontal asymptote. Yes, that is possible, but it only happens towards the center of the graph, and it only happens on the horizontal asymptotes. All right, moving on. Number 4. We are asked to solve this, and because you have both log base 7s on both sides, we can totally get rid of the logs functions, and then all you have is a regular algebraic equation. Distribute, actually, I would probably divide both sides by 3, but I honestly do not remember. Oh, I distributed. So you can distribute the 3 through these two terms. And then when you get rid of or move this -36 or -36 to the other side, you end up with 12y equals 72. Divide both sides by 12, and you get y equals 6. Find the inverse of, so there's two different matrices that we want to find the inverses for. And I know every single one of you is just going to plug it into the calculator. So you set up the matrix in your calculator. You just raise it to the -1 power because that indicates an inverse. And notice the caveat of if it exists. So if you look on my screenshot of my calculator, for this matrix, we get an error message, and that means that the inverse does not exist. And then for this matrix over here, when I raise it to the -1 power, I get all of these fractions. And so that would be my answer. Now, if it's multiple choice, if your answer choices are all in decimal form, to get the calculator to give you a decimal, just make one of these numbers or include a decimal place with one of these numbers. So you could do like 5.0, and then the calculator will automatically convert every single one of these answers to a decimal. So there's a little trick for you about the calculator. Number 6, solve the following system of equations. Again, you would set it up as a matrix, do reduced row echelon form, do the parentheses, put your matrix in the parentheses, and the calculator will do all of the work for you. And with this information, this will tell you that the first number is your x value, so x equals 0. The second number is your y value, y equals 1, and the third number is z equals -5. All right, number 7, what type of conic is represented by the following? So these are all of our different general formulas for our conic sections. The biggest thing to remember, you look at your A value and your C value. In this case, they are different signs, so that is going to be a hyperbola. Okay. Here, your A value and your C value are exactly the same, so you're going to have a circle there. With this one, you have the same sign on the A and the C value, but they are different numbers, so that means you have an ellipse. And then with this one, we only have a C value. Notice my x squared term is missing, so that is a parabola. For number 8, find the 7th term of a geometric sequence. This is the first 3 terms of our sequence. Now for the geometric sequence, you have to find your R value, and to do that, we're going to take any 2 terms that are side by side, and it's going to be the second term divided by the first term. So we're going to do -4.5 divided by 3, and for a rate we get -1.5. we're going to go ahead and plug that rate into our geometric formula, and we want to find the 7th term. So I'm going to have a sub 7 equals 3, which is my first term, times my rate, which is negative 1.5, and that's going to be raised to the 7 minus 1 power, so that's going to be raised to the 6th power. When you plug that into your calculator, that is what your calculator gives you. All right, I believe that was our first problem from our last unit. All right, let's move on to number 9. Here's another, this is a binomial. Don't we love these? It says find the 3rd term in the binomial of the square root of 2 times x plus 3y raised to the 7th power. So a couple things. I'm going to go ahead and expand the whole thing just because I know in class there were several of you that were still kind of confused about how to do this. So I'm going to walk it through. You can rewind this video and watch this section over and over and over again until you understand how to do this. All right, so the first thing we want is we want to find our, actually I'll start with our term on the left, the square root of 2 times x. And the first time we have it, it's going to be raised to the 7th power. The next term, it's going to be raised to the 6th power. And notice that the square root of 2 times x is in parentheses because both of these are going to be raised to the 7th power, raised to the 6th power, raised to the 5th power, raised to the 4th power, to the 3rd, to the 2nd, to the, let's see, 1st power. And then notice there is no square root of 2 times x here because it's raised to the 0 power, which just gives us 1. Now that we're down here, we're going to start with our 3y raised to the 7th power. Then it's going to be 3y to the 6th. And again, notice the parentheses. Then to the 5th, to the 4th, to the 3rd squared, and to the 1 power. And then this would be the 0 power. All right, now we're ready for all of our terms from the 7th row of Pascal's triangle because of the 7th degree. First term is 1, 7, 21. I actually do not have these memorized. 35, 35, and then we'll have 21 again, and 7 again, and then 1 again. All right, so now we have all the numbers, but we have to multiply everything together. So the x is just going to be raised to the 7th power here, but the square root of 2 to the 7th power. We would have the square root of square root of 2 raised to the 6th power, which I think is 8. No, yep, it is 8. And then my extra square root of 7 gives me the square root of 2 raised to the 7th power. Sorry, square root of 2. All right, and then my x is raised to the 7th power. My next term, I have a 7 here, the 3 here, and then 2 raised to the 6th power. So it's going to be 7 times 8 times 3, which gives me 163 x to the 6th power times y. And then my next term, I'm just going to uncover everything. And I could keep on going and do every single one of these terms. However, I just need to know what the 3rd term is. And this right here is my 3rd term. Let me highlight it for you. All right, so that's my 3rd term. Okay, if I really had nothing else better to do, I can keep on going, but I only want to know about my 3rd term. All right, there's that. All right, number 10. We're on number 10, only 40 more to go. Okay, find the value of log base 7 of 89.4 using change of base formula. So guys, here's a caveat. I copied this right out of the district's semester exam test. And I went ahead and kept this because I wanted to show you that with our calculators, we can just change the base on our own. We don't have to use the change of base formula, but in case if you did, you would get the same answer. So here I just plugged it in log base 7 of 89.4. Here I did the change of base formula, and this is what they did like 30, 40 years ago when we didn't have calculators that would allow us to change the base automatically. All right, moving on. Now we want to solve for x. We're going to have to convert this into a logarithm. So we're going to keep our base, which is 7, switch the 4 with the x minus 5 is going to be on the other side of the equal sign. I'm just plugging, so then log base 7 of 4, I plug into the calculator, and the calculator gives me this number. But remember, this number equals x minus 5, so to get x by itself, I have to add 5 to that, and that gives me my final answer, which is here. Number 12, put the following matrix in row echelon form. Okay, so now this is not reduced row echelon form. So reduced row echelon form has like all the zeros down here, all the zeros up here, and then diagonal ones with just regular numbers here, and those are the numbers here are your solutions. That's reduced row echelon form. With row echelon form, you have zeros down here below your diagonal, but not on top of the diagonal. So I just plug that into the calculator, and this is what I get. Notice you have the zeros below your diagonal ones, but you have values up here and then values here. So on your calculator, instead of doing RREF, it's just REF is row echelon form. All right. Identify the conic section with that equation, write this equation in general form. So we've got fractions, we've got a plus sign, so this is an ellipse. And the biggest thing with, well, there's two things. We want to go ahead and FOIL both numerators. So in this numerator, I just FOIL it, and this is what I get for my numerators. And then I want to get rid of my denominators. And so sometimes you have to multiply both fractions by, or you have to multiply everything by both fractions, but because 100 is divisible by 25, all you have to do is multiply everything by 100. And so when we do that, we get 4 is left over here because 100 divided by 25 gives us a 4, and we have to distribute the 4 through here. And then with the y fraction, we just lose our denominator, and then 1 becomes 100. And then when we distribute the 4 throughout this set of parentheses, this is what we get. And then the last thing is put everything in the correct order. So your x squared term, your y squared term, your x term, your y term. And then you need to add up all of your constant terms. And notice I moved this 100 over to the left side because we want, in the general formula of the equation, it equals 0. Like this example up here, we wanted 0 there. So I moved the 100 over. By subtracting, I combine, let's see, 36 plus 4 minus 100 gives us negative 60. All right, multiply matrices. So again, I'm 100% sure every single one of you is just going to use your calculator. So to multiply, we have two matrices. This is matrix A, this is matrix B. We want to find A times B, and we want to find B times A. Okay, and hopefully you remembered that when you're multiplying, you have to figure out what the dimensions of your matrix are. So this matrix A is a 2 by 2 matrix. Matrix B is a 3 by 2 matrix. And in this case over here, we're multiplying B times A. So matrix B is first, and then matrix A, excuse me. Now, hopefully you remembered that if your dimensions are not if this value does not match this value, then you cannot multiply the two matrices together. So the inside numbers have to match, and then the outside numbers tell you your dimensions of your resultant. So when we do A times B, we just get an error message saying that the dimensions are messed up. When we do B times A, so a 3 by 2 times a 2 by 3 gives us, our resultant is a 3 by 2, and this is our answer here. Sorry about the sounds of me drinking water, but if I don't drink water during this, I'll have a sore throat. All right, evaluate log base 4 of 65. Everybody just plugs it into the calculator. If you need help remembering how to find log on the calculator, I will show you in the in-class review. 16, what is a horizontal asymptote of the following? Okay, so for horizontal asymptotes, you have to compare the numerator's degree to the denominator's degree. For our first example, our numerator's degree is equal to the denominator's. Second example, numerator's degree is less than the denominator's degree. And the last example, the numerator's degree is greater than the denominator's degree. And so that we have different rules for each one of these scenarios. When they are equal to each other, you have to take the coefficients, the leading coefficients, and set up a fraction. So we have a 1 here divided by 4. So our horizontal asymptote is at y equals 1/4. When the numerator is less than the denominator, it's just y equals 0. There's no formula whatsoever. That's just your answer. And then if the numerator's degree is greater than the denominator's, then there are no horizontal asymptotes. You end up with a slant or oblique asymptote. And to find that, go ahead and do either synthetic division or long division. I did long division here. I've already walked you through the process once, so I'm just going to uncover all this. And so in this case, I divide my numerator by my denominator, do all the math, and I come up with 4x plus 29. And so my slant asymptote is at y equals x, excuse me, I keep wanting to say x squared. It's at 4x plus 29. All right, for number 17, I highlighted this in yellow because there was a typo on the review, and I fixed it in the video review. Okay, so this, go ahead and fix this. It should be natural log of x plus natural log of x plus 14 equals natural log of 51. Okay, now I know some of you say, hey, you've got natural logs everywhere. You can just get rid of all of them and just do x plus 14 equals 51. But you cannot do that. You have to condense the left side first. So because you're multiplying those two terms, or excuse me, because you're adding the two natural logs together, you would multiply the two terms, and then it's all condensed to one natural log. And now that we've condensed it, now we can just drop the natural logs, and we have x times x plus 14 equals 51. Go ahead and distribute, move the 51 over, set it equal to 0, and you want to go ahead and factor that, and then you're going to set both factors equal to 0. So x minus 3 equals 0, and x plus 17 equals 0. So for your solutions, you get, when you solve for x here, you get x equals 3. When you solve for x here, you get x equals negative 17. And guys, it is going to be a multiple choice test, and both of these answers are going to be on there. And one of them, like you might have just x equals 3 for one of the options. You might have just x equals negative 17 for one of the options. And then you might also have both options to choose from. If you choose both options, in this case, it will be wrong because remember, if you have a negative, you cannot find the log or the natural log of a negative value. So if you end up with a negative anywhere in the natural log portion, it's going to be undefined. Okay, so natural log of negative 17 is going to make this whole thing undefined. All right, so the only real solution would be x equals 3. Number 18, given e raised to the x power and g of x equals 1/2 e raised to the x plus 2 power, how does the graph of g compare to the graph of f? This is just explaining your transformations. Okay, so with the 1/2, you're going to have a vertical compression by a factor of 1/2. And then you're also going to have a shift to the left because of the x plus 2 up here. It's going to shift your graph to the left. Oh my gosh, this is pretty easy. What conic shape is created by the general equation? So my A is positive 1, my C is positive 1. So that's going to tell me that I have a circle. And then they want me to rewrite the equation in standard form. So let me see. Why do I have purple? Okay. Oh, that's right. Okay, so the first thing we want to do is separate our x values and our y values. So I've got x squared minus 8x and y squared minus 2x together. And then my constant term, the 3, I move to the other side of the equation. And now we are going to try to get perfect squares. So what we have to come up with a value that we're going to add here that will make this a perfect square. So we're going to take our, let me see, how did I do this? Yep, okay. We are going to take our middle term, the negative 8, we're dividing it by 2 and squaring it, and that will give us negative 4 squared, and when we square negative 4, we get positive 16. So here we're going to add 16. Let me see, what is this? Yep, okay, let me just uncover that since I already did it. So hold on, yes. So we add 16 over here because we add it over here. We have to add it over here. And then for the y, perfect square for y, we're taking this negative 2 divided by 2, squaring it. Negative 2 divided by 2 gives us negative 1 squared is 1. So we're going to add a 1 here and here. And then we now have perfect squares, so we can write that as x minus 4 squared. And the reason why I know it should be a minus 4 is because this is what I have over here. Remember, that's going to tell you the number you're adding or subtracting. Okay, and then plus y minus 1 squared. And then when I add up the negative 3 plus 16 plus 1, I get 14. How much time would it take for an investment to triple at a rate of 7.3% if interest is compounded continuously? All right. So this was some of our finance stuff. So a couple things. The formula to find continuously compounded interest is a sub n equals your first term times e raised to the rate times t, which is time. Okay. So we want to know how long it's going to take for our investment to triple. In this case, we are looking for 3 times a sub 1. Okay. I have no clue what my initial investment is. I just know I want it to be 3 times the amount. So it's just going to be, we're looking for 3 times a sub 1. That's going to equal a sub 1 times e raised to the 0.073 times t. Okay. And so the easiest thing to do, divide both sides by a sub 1. That's going to leave us with 3 equals all of that. And now we want to get rid of our e, and to do that we're going to do the natural log on both sides, and that will get rid of our e. So we'll have we'll have natural log of 3 equals this. To get t by itself, we're going to divide both sides by our decimal or our interest rate. So we have natural log of 3 divided by 0.073. That's what we're plugging into the calculator. And when we do that, our calculator tells us it's going to take us a little bit more than 15 years for our investment to triple. All right. Number 22. If you have this and this, we want to find f plus g, f minus g, f times g, and f divided by g. Whole bunch of stuff. All right, so if we're just adding the two functions together, all you're doing is adding them together and combining like terms. Super easy. If you're subtracting, you're subtracting. The biggest thing is remember that on the g of x, both terms are going to be subtracted. So notice I have it in parentheses. And again, combining like terms, but notice that minus 4x and minus 3 gives us this instead of this. When you have to multiply the two terms together, you're going to be foiling, and everybody remembers how to foil, right? If you don't, I just foiled it really quickly. Once you're done foiling, combine like terms, and that's what you get. If you are dividing, a lot of times when you're dividing, there's not a lot to do. In this case, I just set up f of x is in the numerator, g of x is in the denominator. I guess you could go ahead and factor out an x up in the numerator, but it really doesn't matter because there's really nothing else to do with it. The biggest thing is if this is what your answer was and it wasn't one of the multiple choice options, would you recognize this as being equivalent? I think that's the biggest thing to remember. Let's see. All right, now on to composites. So we're going to make a composite of f of g and a composite of g of f. And notice I used the two different formats for doing composites. Either way, whatever's on the inside, whatever function's on the inside, that whole thing is going to go inside the other function, or the x's on the other function. So in this case, we just replaced our x here with 3x divided by x minus 2. I probably could have expanded this, but I didn't because I'm tired and I'm lazy, and it's okay. Hopefully you guys all know how to expand it, but even on the test, I don't think it's expanded. All right, so now for g of f of x, again, this time f of x is on the inside, so you're taking this equation and replacing these x's with it. I did go ahead and do a little bit of combining like terms here and simplifying. So I distributed the 3 and I combined like terms here. So this would be my answer here. All right, 24. We are almost halfway through. Yay! What limit on the domain would make the functions one-to-one functions? Okay, so a couple things on these. All these graphs, or all these functions, I went ahead and graphed them, and the reason why is because you really need to see what the graph looks like to understand how to limit the domain. So in this case, this function looks like this. It's the absolute value. It's smack dab centered on the y-axis, and for a one-to-one function, for each x value, there's only one y value, and for each y value, there's only one x value. But if you look here, these two x values have the same y value, so it's not one-to-one. So basically what you need to do is you need to get rid of the left side of your graph, okay? So what we're doing is we're just limiting the domain, so the left side is gone. And so here is how I limited the domain. I just said that x had to be greater than 0. So notice that this whole left side is just gone, and now it's a one-to-one graph. Okay, next equation for b, we've got, this is what our graph looks like. Here, we want the vertex here. We want to know where this vertex is, and if you look on it, 1, 2, 3, 4, 5, it's at -5. And so again, I want to get rid of the left side of the parabola, and so I'm just going to say x has to be greater than -5 because that's where it starts going up and we get double values, or double y values. All right, for c, we've got a fraction here. This is what our graph looks like, kind of funky, but you'll notice, let me move it up, that you have this vertical asymptote here. And if we just limit it to x has to be greater than 0, then you'll get rid of this side of your graph, or you'll get rid of the left side, and so we'll have just a one-to-one here. Voila. So we just limited it to x has to be greater than 0. And the last one, we have this cubic function. This is what the cubic function looks like. And let me move it back up. So all the other ones just had 2 terms. This one actually has places where you have 3 different x values for all the same y values. So instead of limiting it just at the center of your graph, because you would still have this part here. You have to find the minimum value here, and you're going to use that x coordinate to limit your domain. So it's going to be x has to be greater than 1.63. Okay. All right, limit on our domain. Come on. There we go. All righty. Let's see. What is the domain of this function? I'm trying to remember what I did. Did I graph it? Let's see. Yep, I graphed it. Woohoo! There's my graph. I absolutely love graphs. There's so much you can find on the graphs. And just based on this graph, it looks like you have an asymptote here at -1, and you probably have an asymptote somewhere around between, let's see, probably 2.5 and 4 maybe. So in this case, because I'm not 100% sure where this asymptote is, I'm going to totally just look at the table. So I pull up the table, and indeed, when x is -1, I have an asymptote there. And this table also tells me that when x is 3, I have an asymptote there. So that's going to help me figure out my domain for the function. And I'm going to say it goes from -infinity, because over here it's going to keep on going this way forever, to -1, where my first asymptote is. Then I do the little break thing with this u, and then from -1 to 3, notice I'm using parentheses everywhere because of the asymptotes, and then another little u, and then at 3 to positive infinity. Number 26, which of the following are power functions? So power functions are, you have x and is raised to some exponent, some power. Okay, that's what power functions are, and there can only be one term for it to be a power function. So right here, because we have two terms, this is actually a polynomial function, not a power function. So here where we have x as the base number and it's raised to some power, that is a power function. So b is a power function. Here, where you have a number raised to the x power, this is an exponential function, so this is not a power function. And then d, you have x raised to the third power. Even with this negative in front, it's fine because there's only one term here. So the function b and function d are power functions. Function a is a polynomial, and function c is an exponential function. All right. 27. The height in feet of a ball thrown in the air after 2 seconds is given with this equation. Use synthetic substitution to find the height of the ball after 0.25 seconds. I'm absolutely sure none of you are going to go through this, but I'll show you just in case. Set up your coefficients, put 0.25 in the little corner box, do all the math, and your remainder is 15.5. So this is telling you that if you plug in 0.25 in for t, this is what you will get. That's one of the cool things about synthetic division. But another way you can do that is you can just plug in the formula in the calculator, replace all the t's with 0.25, push enter, and the calculator tells you it's 15.5. Either method works. I'll let you choose which one you do. All right, 28. Calculate the eccentricity of the following conic functions. So we have a hyperbola, an ellipse, a circle, and a parabola. I'm going to do the eccentricity for the circle and parabola first, because those you don't have to calculate at all. The circle has an eccentricity of 0, and a parabola has an eccentricity of 1. Okay, now for the eccentricity of the hyperbola, it's going to be, you have to know your a and your b, and so square root the denominators. So square root of 25 is 5, square root of 36 is 6, and with that information you have to calculate c, and so it's going to be the square root of 25 plus 36. For the formula to find c for the hyperbola is you add the two square terms of a and b, and then you square root that. So that just gives you the square root of 61. I believe 61 is a prime number, so we're just going to leave it square root of 61. Now for the ellipse, notice that your a and your b value is going to be the same because you have the same denominators over here. In fact, the only difference between this function and this function is the plus and the minus, but that plus says that this is an ellipse. So I'm going to use the different formula to find my C value. That would be the absolute value of 25 minus 36. And when you calculate that out, you get the square root of 11. Go ahead and leave it as square root 11 for C. And then for the eccentricity, for your hyperbola, it's going to be C over your positive fraction. And this is our positive fraction, so A is going to be what's in their denominator, so it's going to be the square root of 61 over 5. And if it's a multiple choice and you don't see that option, then go ahead and calculate that out, and when you do, you get 1.56, which the eccentricity for our hyperbola should be greater than 1, so we're good there. For our ellipse, we do the same thing, except we're still going to have C in the numerator, in the numerator, but in the denominator, it's going to be whatever is the bigger radius, either A or B. So in this case, B is our bigger radius, so we're going to do square root of 11 divided by 6. And again, if the multiple choice options don't show absolute value or the exact value, plug it in, get a decimal, and that's what you get. All right, that's finding the eccentricity for all 4 types of conic functions. This one we're going to solve. This is another one where if you wanted to, you can just graph the whole thing. So graph this portion here in one function, and then graph this function here in the other function, and then find where the two intersect. So you can totally do that. Or if you want to do all the algebra, you have to get a common denominator in order to combine these fractions. So it ends up being our common denominator is just this denominator here. So we're just going to multiply this fraction here by x plus 6 over x plus 6. This fraction gets multiplied by x minus 1 over x minus 1. We multiply everything out. We find the combined like terms. And let me see, what else did I do? Oh, I also, now that we have common denominators, you can move this x minus 3 over. So we get this whole big thing. And then let's see, what else did I do? Oh, yeah. So you can totally get rid of your denominator now by just multiplying both sides by the denominator. And anything that's multiplied by 0 is just 0. So denominator's gone. Okay, and then the next step in the algebra is putting it in the quadratic, putting your A, B, and C in your quadratic formula and doing just tons and tons and tons and tons and tons of work to eventually get that your two answers are negative 16 over 6 and negative 6 over 6. Honestly, it's a whole heck of a lot of work. I would just graph it. In fact, I think I did graph it, but I just graphed this one here. So I just graphed the combined numerator, but you can totally just, like I said earlier, graph the left side in one function, graph the right side in the other function, and find where they intersect, and you'll get the same answers no matter what. But notice when you graph this, your answers are in decimal form, and if your answers, if it's multiple choice and they're not in decimal form, then you'll need the exact answer. But you know what, if you type in negative 16 divided by 6, you would probably get negative 2.67 if you have the calculator give you the decimal. So that's just another quick fix to save you time on the test. All right, number 30. I remember why I put these highlighted in yellow. This is another typo. For some reason, the numbers up here I changed, but I did not change any of the answer choices. So all the answer choices are like really wrong on problem 30 on your review. So go ahead and change it to the ones I have here. So with this one, you just have an inequality, and you want to know what the solution to this inequality is. There's a lot of ways that you can do this algebraically, but I find that, again, I love my graphs, so I'm just going to graph it. And when you graph it, you get this huge graph, right? And again, if you need help figuring out how to graph inequalities, I can show you in class when we do the review in class. So we have this graph here where you have the dotted lines and then it's shaded over here and then dotted lines and it's shaded over here. So what this means is that you have two different scenarios. So and it's going to keep going shading over here to and keep shading over here to infinity. So you can say that x can be from negative infinity to negative 8, and notice we're doing parentheses because of the dotted lines here, or, and the reason why it says or is because none of this center is shaded in, your x can go from 6, anywhere from 6 to positive infinity, okay? So that's how you would interpret that graph. Yep, moving on. Find the polynomial function of least degree with real coefficients in standard form that has the following zeros. Okay, so scenario 1, you have a 0 at -2 and 3i. Hopefully you remember that if you have one 3i, if you have a positive 3i, you also have a negative 3i. So you would set up your factors by this, and then you could either box or foil. I think I just foiled. Let me see, what did I do? Oh, I foiled these two terms. Anytime you have anything complex, like an I or a square root, you want to foil those two terms together because you can cancel out. You know what? I totally did not finish this. Because these terms cancel out, and so x minus 3i times x plus 3i just becomes x squared plus 9, and then you would multiply x squared plus 9 times x plus 2, and I bet you guys can FOIL those together. If you need help, ask on whenever we're taking our test or during our review. Okay, now I wanted to show you both examples because on your test you may have a 3i, or you may have an I, or you may have a radical. So either one, if you have one, you have two. So you have to set up both fractions. The difference here on this side, when you, negative square root of 3 times positive square root of 3 gives you a -3. And then you're going to end up with x squared minus 3 here. All right, moving on. Oh, gosh. Okay. Which describes the end behavior of the following functions. These, you do not have to actually graph these polynomials to figure out what the left and the right side of the graph does. If you remember the rules, it all has to do with the sign of your leading coefficient, whether it's negative or positive, and your degree here. So if we have a negative leading coefficient, then the right side goes down. And if our degree is an odd number, then the left side does the opposite of what the right side does. So in this case, the right side is going to go down and the left side is going up, and d is a 1. So as x approaches negative infinity, so the left side of the graph, it's going to go up, and when x approaches positive infinity, that means the right side of the graph, it's going to go down. Okay, so and then because we have a positive leading coefficient here, the right side's going up and the left side's going down because of our odd degree. So that means example C, or option C, is our end behavior. So here we have a positive leading coefficient, so the right side is going up, and because our degree is an even number, the left side is going to do exactly the same as the right, so both sides are going up, and option A is the one that tells us that both sides, both the left and the right side, is going up. And then our last term, or excuse me, oh my gosh, I can't talk anymore. Our last problem, we have a negative coefficient, so the right side's going down, and because it's an even degree, the left side is also going down. So we have option B has both sides going down. Almost. We're about, what, 3/4 of the way done? What is the greatest possible number of real zeros of this polynomial? Just look for your highest degree. In this case, it's 7, so you can have 7 real zeros. What is the focal length of the following conic equations? So we have 3 different conic functions. This one is an ellipse because of the plus sign. a hyperbola because of the minus sign, and a parabola because we do not have an x squared term. And to find the focal length of all three of these, well, for the first two, excuse me, you have to know your a value and your b value. So your a value is 10 because square root of 100 is 10, and b is 6, square root of 36 is 6. And then for the formula to find your focal length, which is your c value, for the ellipse, you're going to do the square root of a squared minus b squared, so 100 minus 36, and that gives you the square root of 64. Square root of 64 is 8. And then for the hyperbola, we notice that we have the same denominator, so same a, same b. Your formula is going to be the square root of a squared plus b squared. That's really important to keep straight. The ellipse, you're subtracting. The hyperbola, you're adding. When you add that all together, you get the square root of 136. If you don't have the square root of 136 as one of your answer choices, go ahead and convert it to a decimal form, calculate it, you get 11.66. And then for the parabola, to find your focal length, it's going to be 1 divided by your a value times 4. Okay, so we have 1 divided by 4 times a. Doesn't matter whether it's the a is first or the 4 is first, which is 1/2. 4 times 1/2 is 1/2 is 2. So 1 divided by 2 is just 1 divided by 2, or 1/2. All right. We are, for 35, we are graphing. Let's see, graph this equation. In your example, or on your worksheet, I went ahead and graphed the parent function of 4x, and I know that all of you are just going to graph it in the calculator, but the cool thing is that you're just taking this graph and shifting it over 3 units. So if you start here, it's going 1, 2, 3 units to the left because of the plus sign. If it was a minus sign up here, it would be moving it 3 units to the right. Okay. Which relation's inverse is a function? For that, we want to, let me insert a line. I want a horizontal line. Whoops. All right, here's our line. The reason why I drew this, have this line, is because I'm going to do the horizontal line test. With the horizontal line test, you move it back and forth. If it intersects more than one point at any time, then the inverse is not a function. Okay, so A is not going to have the inverse be a function. C is not going to be a function. Do the same thing. D is not going to have the inverse be a function, but B is, because notice for this is your equation right here. You're only intersecting once on all of those places. So B is the function that will have the inverse is also going to be a function. All right. Piecewise function. So we want to find f of -9, f of 9, and f of 1 with this piecewise function. So if x is -9, then we're going to use the top equation, because this says use the top equation when x is less than 1. So -9 is less than 1, so we're using the top equation. We're just plugging in -9 into the equation and solving, and we get 30 there. Absolute value of -6 is +6. -5 times +6. Oh, that should be -30. -30. All right. And then if x is 9, then your x value is greater than 1. So your value is just going to be -10. Notice when at this time x is 1, and because the equal line is down here, then if x is 1, it's also going to be -10. Finding zeros of polynomials. Okay. First thing I want you to do is graph. Okay, when you graph it, you should have 4 exponent or 4 x-intercepts, excuse me, and you do have all 4. But guys, on this one, you are going to have to know the exact value of your x-intercepts. For -7, it does land right on the tick mark. For 3, it lands right on the tick mark. But for this one, it's somewhere in between, and for this one it's somewhere in between. So we're going to use those x-intercepts, the whole number x-intercepts, to do synthetic division to figure out where our other two are. Now, I always like to pull up the table just to confirm that the ones that look like they land on the whole number x-intercepts actually do, and so I just pulled up my table and it did. So let me see. We do the synthetic division. I always start with the smaller numbers. When I started with the smaller number, I do all the synthetic division. Let me just get rid of this. And I get these terms, and then I'm going to use my next number, -7, and do synthetic division again. And notice that my remainder in both cases are 0. It should be 0. If you get anything else for a remainder, then you've messed up somewhere, or it's not an x-intercept. Okay, then we get the terms 1, 6, and 3. And with 1, 6, and 3, that's going to be your A, B, and C. Let me see. In your quadratic formula. So you can go ahead and plug those into your quadratic formula. And remember, I know I went over this in class when we were doing this unit. With these, you can these are all your coefficients, and you can plug them back in. This number here is going to be your constant term. This will be multiplied by x, and this one will be multiplied by x squared. So that's how we know that it's A, B, and C value. Plug it into your quadratic formula. Simplify as much as you can. Square root of 24, if we plug that in the calculator, it gives us a decimal, but we can simplify that by doing the square root of 4 times the square root of 6, and the square root of 4 is 2 times the square root of 6, so I'm going to reduce that further, and then what we get, is the square root, we get -6 plus or minus 2 times the square root of 6 divided by 2. Then we can divide both those terms by 2, and our last two x-intercepts are at -3 plus square root of 6 and -3 minus square root of 6. Okay, so again, multiple choice answers, but they're all going to be exact answers, no decimals on that one. 39. The height in feet of a flare t seconds after it is shot is modeled by this equation. Find its average speed from 6 seconds to 8 seconds. Guys, I totally just graphed this and pulled up the table. I want to know what is my y value when x is 6 and when x is 8. And then I'm going to just use my slope formulas. So the y2 minus y1 divided by x2 minus x1. And I've been doing this with my Algebra 1 kids, and they totally freak out if I don't have the, if everybody should have this as the x and y1, and everyone should have this as the x and y2. But I keep trying to tell them it's going to be the same no matter which one is your 2 and which one is your 1. Notice that I've put it up in both forms, and I calculated it both ways, and no matter which way you calculate it, you get -41 as your answer, which means, let's see, height in feet after 2 seconds. No. Oh, we're looking for our average speed. And so our speed is actually going to be like 41. Does it tell us how many meters, seconds? What? After a shot model, okay, yeah. So it doesn't give a measurement of kilometers, miles, feet, whatever. So our answer is just basically our speed's going to be 41, but because of the negative, that's telling us it's dropping instead of going up. Okay, just FYI. Moving on. For the following functions, describe the transformations of the graph of f of square root of x. Okay, so what's happening? We have two different ones. So again, we've done a couple transformation ones. With the 1/2 up front, it's a vertical compression by a factor of 1/2. And then the 3 here is going to be a horizontal compression by a factor of 3. So notice this is your B value here, and it's going to be a horizontal compression if it's greater than 1, and a horizontal stretch if it's a fraction or decimal. All right, so there's our horizontal compression, and then we are also shifting to the left 5 units and then up 7 units. Okay. Notice, okay, so now with this one, vertical stretch by a factor of 2, because with our A value, if it's greater than 1, it's a stretch. If it's a fraction or decimal between 0 and 1, then it's a compression. And then because our B value is 1/3, that's going to be a horizontal stretch by a factor of 1/3. And then we're shifting 4 to the right, and we're shifting 6 units down. Okay, graphing that equation. This is the absolute value. Guys, if you need help graphing absolute value, let me know. But there's no secret to it. Just plug it into the calculator. There you go. 42, right? X raised to the negative 5th power equals 1/9 in log form. So with that, you need to remember that if you have an exponent like a raised to the b power equals c, you're going to convert it to a log. You're going to keep your base, and our base is a, and then you're going to switch the other two values. So the c and the b value is going to be switched. So we're going to keep our 7 as our base, and we're switching the 1/9 and the -5. Okay? And what's funny is a lot of times these type of questions don't actually equal what it is, because like I just randomly picked these numbers. I'm pretty sure they are the log base 7 of 1/9 is, I'm pretty sure it's not -5, but just FYI. All right, moving on. Solve this log function. Again, you have to compress the left side before you can just get rid of all your log base 3's. So because you're subtracting, you're going to be dividing by 10. And now we can get rid of our log base 3. And we want to, so we end up with this. We want to get rid of our denominator. So we're multiplying both sides by 10. Gets rid of the denominator. It makes the 2 become 20. Subtract or add 9 to both sides. Guys, at this point, it's just algebra. You end up with the square root of 29. But remember, it's always positive or negative square root of 29. And remember that it may be one answer, it may be both answers. You have to plug it in back into the original equation in for x and make sure you're not going to have you're not looking for the log of a negative number. But cool thing is because we're squaring our x value, it works both ways. So both of these are going to be solutions to the log function. All right. Graphing this, again, just plug it in, guys. Plug it in, plug it in. Here's your regular parent function. With this, you're shifting it to the left 1 and up 2. So this point here goes left 1, up 2. Expand this. So remember the 3 up front is going to be exponents for each one of these terms. Okay. So the first one, log base 5 of 6 raised to the 3rd power, plus, because each of these terms are being multiplied together, you're going to separate each log function with a plus sign. Log base 5 of x raised to the 7th power raised to the 3rd power, and then plus log base 5 of y squared raised to the 3rd power, and then log base 5 of z raised to the 3rd power. You do need to go ahead and calculate anything that can be, or simplify anything that can be simplified. So 6 to the 3rd power is 216. X to the 7th to the 3rd power becomes x to the 21 power. And then y squared to the 3rd power is y to the 6th power. And you don't have to do anything to z to the 3rd power. All right, 46, write the standard form of the equation of a circle with the center at 3 and -5 that is tangent to x equals, to the x-axis. Oh, shoot. I totally made it tangent to the y-axis. All right, totally going to have to change my formula, but hopefully you'll be able to figure out what it is. All right, so first of all, Your tangent, to have a tangent, it just means a tangent's a straight line or plane that touches a curve or a curved surface at a point but does not cross that point. So basically, and I messed up my circle. My circle should be touching up here. So it is going to change our whole formula. So let me just make another circle. Let me see if I can insert a circle. Circle. There we go. Let's say we have a circle and I want it to not be filled in, but I want a thicker line. Oops. Let me make a thicker line. And I honestly have no idea how wide this should be, but I do know that it should touch the x-axis right at 3. We're going to pretend that's there. And then it should, let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It should have a radius of 5. There we go. Which means that this needs to go out, let's see, to 8. So right there. And then this probably needs to go out to over here somewhere. All right, there we go. There's our circle. It's touching the x-axis, but it's not like crossing over the x-axis. So that means that I need to change my answers over here too. All right, so basically let's totally ignore the blue circle, pretend it's not there. We're looking at the black circle. This is your standard form for the circle. And your H and your K is going to be your center point. So because my center, let's see, where did they give us our center, right? Yes, they give us our center at 3 and -5. So it's going to be x minus 3 squared plus y plus 5 squared. And then you get rid of this. And then our radius, because we're not doing the blue circle, we're doing the black one. Our radius is 1, 2, 3, 4, 5. So it's going to be 5 squared. And yes, you can go ahead and write that as 25. In fact, a lot of times on your multiple choice options, it'll probably say 25 and not 5 squared. Okay. Last set of problems. We have a conic application problem. And one of my students in tutoring, I think it was Miger, maybe it was Hannah, I totally don't remember. One of you girls said, do Jupiter. So we did Jupiter. And I went online, found the major axis of the orbit of Jupiter around the sun. But they did do kilometers because, you know, I don't know, I guess it's more scientific. And then they also gave me the eccentricity for Jupiter. And then for this, you want to find A, B, and C, and then set up your standard formula. So in this case, to find your A value, you're taking your major axis and dividing it by 2. And you get this. I think for most of this, on the answers, I rounded to 3 decimal places. It's multiple choice. I'm sure you can, hopefully most of you guys can round or pick the rounded answer. And then for this, for the eccentricity, because A is my major axis, or my bigger than B, it's going to be, eccentricity is going to be C over A. So I'm going to multiply, I know my eccentricity now and I know my A value now, so I'm just going to be multiplying those two together to find C. And I plug it all in the calculator and this is what I get. So I now have C and I'm ready to find B. So to find B, it would be the square root of A squared minus C squared. And I get that, and simplify everything gives me this. And one thing that you'll notice is that I actually graphed this so I could have a proportion, and it looks very, 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 very close to a circle. And the reason why is if you compare your A value to your B value, they are relatively close in values. So they're only about 500,000 kilometers apart. I know that seems like a lot, but when we're talking about 388 million and 399 million, it's not so much apart. All right, now to do our standard form of the equation. So the biggest thing, make sure you put your C value in for your H, because let's go back up here. The sun is at the origin, and the center of your orbit is C units away from the sun. Okay, so that's why we have C there. Square your A value, square your B value, set it equal to 1, and you're done. And that is our 50th question, and we are done with this review. Good luck. Sorry it was so long. Bye.